Okay, it's 2:01. Let's just go ahead and get going. Lauren's logging in. Wait for her to get in. Okay, I see some of the usuals. So thank you all for tuning in to NextGen Geospatial, the Geospatial Data Science Workshop here at the University of Arizona. We're coming to you from the Science and Engineering Library on campus. It is April 23rd. And we have a special guest today. And so we are not going to do a Jupyter notebook or do any Python coding today. Instead, we're going to talk about Planet Satellite Imagery, talk about what's available to U of A personnel. So myself at the Data Science Institute and another institute at U of A called ICDI, which is Institute for Data Enabled Insight, Institute for Computation and Data Enabled Insight. We purchased a campus-wide license for a whole lot of Planet Satellite Imagery and products that they make. And so today is our special guest is Austin Stone, who represents Planet. I believe you are a customer success manager. Is that what it says on your
You
bio?
you
Excellent.
nailed it. You nailed it.
Excellent. So before we get to Austin, he's the expert. He's from Planet. He knows all about the imagery products and everything. But just wanted to give you guys a bit of information before we launch into it. So we talked about Planet, and that's actually the first session of the semester back in January, and we showed you guys how to use the Planet API. Let me give you just the link to something. Wow, that's a really strange URL. But that is the web page on the ICDI page that can show you how to get access to Planet data. Basically, you just sign up on a Google form, and then we can take your email and give you access. And so you would sign up through your U of A email. So you go to that link and follow the other links in to get yourself signed up, and then voila, you will have access to a whole um, corpus of historical and satellite imagery going forward. And so throughout, if you have any questions about that license, what's available to you, we're going to talk about that in depth. And so Austin is going to actually kind of go through what is in our campus license. We basically have access to 3 meter 4 band satellite imagery. That's called Planet Scope. It covers the entire globe. It is, well, I would say, frankly, amazing. Just the imagery set, and you get it about every day, every other day for almost any place on land on Earth. And I've been using it since 2017 for kind of a variety of reasons. Um, then, well, I'll just turn it over to Austin. And so, Austin, you want to take it away and yeah, start by like talking about what's available to us in the license, and then go from there. I think he's going to talk about planetary insights or planet insights. Sorry, um, that is the brand new analysis platform that Planet has recently just launched. So you could think of it kind of as a cloud computing platform where instead of just taking the data and bringing it to your own computer, you can do analysis right there with their system. So I'm excited to kind of hear some more ins and outs of it and our ability to access it. So I'll turn it over to you, Austin. Thanks for coming.
All right. Well, Jeff, thanks for having me. I'll do a quick little intro so that way you can get to know me and my position at Planet a little bit better. But my name is Austin Stone. I'm a customer success manager at Planet. I work exclusively with our academic communities. So we have a program called the Education and Research Program, where we have a variety of different ways in which students and researchers can gain access to our data. And from the paid licenses front, I engage with all the universities who subscribe to that license. Before I was at Planet, I've been with Planet for almost 3 years now. Before I was at Planet, I was or still am, a remote sensing scientist by trade. I did a lot of work down in the southeastern United States looking at agricultural remote sensing. So we did a lot of drone work, a lot of satellite image analysis to think about how we can scale yield across space and time. And so that kind of led me to my role here at Planet, which is to enable all of our academic users with all the right information that they need to kind of get started on their planet journey. So in this presentation, we'll really, I have a lot of slides, so we'll jump straight into it, but it's really to give you a better idea of who Planet is, the data that you have access to, and how you might get that data delivered to you, as well as some analytical opportunities as well that are new to our Planet Insights platform, which I'm excited to tell you more about. So I'll jump in. Planet's mission is to image the whole world every day and make global change visible, accessible, and actionable. This is a really tall task for the satellite industry. So just kind of rewinding, this was kind of our mission one goal, was to image the Earth every day. And so the way that we did that was by creating a constellation of small satellites that are always capturing over Earth's landmass. And so it took a few iterations, but in 2017, we achieved that mission one goal of capturing an image over the Earth every day. And so this is the Dove satellite, which are equipped with our PlanetScope sensors. We have roughly about 200 of these in orbit. They're always on, they're capturing imagery over Earth's landmass. I should note that these satellites are about the size of a loaf of bread, so they're quite small. But this actually enables us to create new satellites with updated software, updated hardware to maintain the cutting edge of imagery remote sensing. And so to counter our Dove satellites, we have our, which are capturing data at 3 meters with 8 spectral bands. We have the counterpart, SkySat, which is our high resolution tasking satellite. So this is capturing imagery at a native resolution of 70 centimeters with a visual product of 50 centimeters. And it's collecting imagery on an on-demand basis. So someone will actually say, I need an image over this particular area at a specific time. And so with these two constellations, we're actively capturing tons of imagery data over Earth. And so some of that imagery might look something like this. This was a SkySat image over the Tonga volcano that was experiencing some volcanic activity back in early 2022. Well, we captured over that because we were notified by NASA scientists that there was some activity taking place. Well, just a few days later, January 18th, the volcano had erupted, basically taking away all of this landmass that was occupying this particular place in the Pacific Ocean. And so to see that amount of change happen so quickly with satellite data can be very powerful. And so one of the things that is really interesting, even though we're capturing events in a static form, because we're always on, we're capturing data of the impact of an effect like this. So because this volcano erupted, it triggered a tsunami, which in turn tipped over an oil tanker off the coast of Peru, leading to an oil spill, something that imagery was able to capture. And you can actually use this to help quantify the amount of oil currently occupying this space. And then subsequent imagery you can use to track the changes to that. Another example here is this is off the coast of Italy, the west coast of Italy, or east coast of Italy. What you don't see in this image is actually in the interior part of Italy, there is a giant rainstorm taking place. And so along the coastline, you don't really see that impact of something that's currently happening on the interior. Well, fast forward a couple of days, and all the sediment basically funneled into this river system and actually created this sediment plume. And so because we're always capturing that imagery, we're able to see changes right before, right up until, and then actually right after. So just a few days later, that sediment plume has turned into just a mass of sediment across the coastline. And then we can actually take this and zoom out. That was just one river that we were looking at, but if we zoom out, we can actually see that this rainstorm had a bigger impact across the entirety of the coast of Italy. So just a really cool example of how satellite imagery can be used. Another example, early last year, this was an image of what Lahaina in the town in Hawaii that was impacted by the wildfires looked like. So we kind of use this as this is captured by SkySat, so you can really tell the building details. But you can kind of see what the town is supposed to look like. Fast forward to August of last year, and of course, we're all familiar with the wildfires that came through and devastated this town. Well, our imagery was able to capture the impact of this. So you can actually see over the same area just how devastating a natural disaster like this can be. And so we actually partner with people like the Microsoft's AI for Good Lab and the American Red Cross to use this information to help build out useful information for tracking things like, in this case, building damage, which was something that was rapidly produced after this image was collected. The model that was used to produce this building damage, which is helpful for figuring out where resources might be allocated during this time, was actually a model that was produced in response to the Turkey earthquakes that happened either earlier in 2023 or late in 2022. I'm blanking on the time frame, but that goes to show you just how this imagery can be used for a rapid response. And so other ways that our imagery are being used, just more broadly speaking, we are partnering with a company called Synthetic, and they are the ones who helped track down the balloon that everyone was talking about early last year. One of the ways that they did that was based off of known sightings. They were able to actually identify in the imagery where this balloon was located. And then they created an AI model to actually search for the imagery across our archive. And because they were able to do this, they were able to identify other dates in which our imagery had captured pictures of this balloon, but also the inception of the balloon back in China. So just a really interesting and unique way that our data is being applied for real world monitoring situations. And then, of course, more recently, this was a SkySat image over the Francis Scott Key Bridge, just a couple of days after the cargo ship had run into the bridge, which is incredibly unfortunate. But our imagery being always on is capturing information like this. And so this can help facilitate search efforts, allocate resources appropriately, and take action. And so those were just a few different ways in which that our imagery can be used, and just to really just show you some really beautiful images as well. But to kind of break it back down, the satellites that are capturing these images are the Dove satellites. Again, these are those the small satellites about the size of a loaf of bread. They're capturing imagery at about a 3-meter spatial resolution. We have about 200 of those in orbit, and they're equipped with 8 spectral bands. You have coastal blue, blue, green 1, green, yellow, red, red edge, and near infrared. So we're capturing quite a bit of information across the electromagnetic spectrum. And then, of course, we have the SkySat imagery that are capturing the highest spatial resolution imagery. Just a quick little breakdown. Here's just an example image of what that SkySat image looks like. You could really see the detail of all of these containers here, as well as some of the vehicles actually parked in the over here, parked in this facility. Conversely, we have the Super Dove, the Dove satellites. We have so many different renditions of these satellites. So we have Dove Classic, Dove R, and Super Dove. We'll dive a bit more into those in a minute, but this is an example of what the Super Dove image would look like. We took this image over some agricultural fields. Agriculture is one of the major users just because we have such a high temporal cadence. So we're capturing those imageries on a near daily basis. So what that allows us to do is see what's happening in the field and be able to make decisions within that field very quickly without having to be on site, so saving resources for farmers and allowing us to take action more quickly. And one thing that I wanted to call out that's really unique about Planet satellites is that we use this term agile aerospace to describe how we actually engineer and manufacture our own satellites and put them into orbit. And so one of the really cool things is with the Dove satellites, because they're so small, we're able to, and we have the manufacturing expertise and the workflow in place, we're able to update these on a frequent basis. And so over the past 10 years, we've had 17 different Dove builds. And so we're actively replenishing that constellation over and over and getting the most updated hardware on those sensors or on those satellites. It takes about 3 to 6 months to design one of these satellites. So, and what I mean by that is, the components and the hardware and how we decide to manufacture it. And so this is really exciting because we get to use that the most cutting edge technology on the market for an affordable price. And so over the past 10 years, we've been collecting data and building out an archive. And ever since 2017, we've been capturing an archive of Earth's landmass on a near daily cadence. And so one of my favorite stats about this archive is about any point on Earth's landmass, you have access to, on average, 2,000 observations. And what I mean by observations are 2,000 individual pixels that are telling you something about what's happening on that space or on planet's surface at a very specific point in time. And so this is really incredibly useful for you to think about things from a machine learning or deep learning or AI approach, where a lot of data is actually needed to train particular models for particular anomalies to detect. And so it provides a really deep historical context across Earth's landmass. And so you might be able to find a lot of value in having that near daily cadence across time. And then, of course, our platforms itself for you specifically too, we'll dive more into exactly what you have access to. But this archive includes things like the PlanetScope constellations or data, RapidEye data, SkySat, Landsat, and Sentinel-2, all within your access. Another thing that Planet has been working on, so historically, Planet has been an imagery first type company, but obviously we know that the value of our imagery relies in the insights that you can derive from that imagery or other remote sensing data. And so some of the things that we've been working on are called planetary variables. And basically what these are is we have a group out of Haarlem in the Netherlands that are generating these derivative products that we're calling planetary variables. They're using a variety of different remote sensing data sets that are available, publicly available data sets, and other localized data sets to help produce these products that are telling you more information about a particular place at a particular time. So what we're working on now are things like soil water content, land surface temperature, crop biomass, forest carbon, as well as forest structure characteristics. And then recently, actually, within the past couple of weeks, we've just released our new field boundaries layer. So being able to actually create a vectorized layer for field boundaries. And so we'll talk a little bit more about what U of A has access to in terms of these planetary variables, but they're a really exciting way to get people the information that they need without having to do any sort of the modeling. Here's a quick little breakdown of all of these planetary variables and their resolutions, whether that be spatial, temporal, and of course their spatial extent. I'm not going to dive into these in detail, but all the things that I have highlighted in this particular slide, this is what is included in the U of A contract. It is a limited availability and is available upon request. So reach out to Jeff. I'll put you on the spot. Reach out to Jeff and he can help facilitate those requests. But it could be a really interesting way to utilize different planet information. Okay, so breaking down the access that you all have. So everything that we've covered up until this point, we've been talking about the imagery products that we create. So you have access basically to the entirety of the PlanetScope archive. And so that includes the near daily data being collected at roughly about a 3-meter spatial resolution in 8 spectral bands. 4 spectral bands historically, but 8 bands since 2022. So that's more recent. And this includes the global archive. We have visual data products, we have surface reflectance data products, as well as top of atmosphere reflectance. So depending on your needs, we have access to those. You also are given access to our global monthly visual base maps. So imagine, each image is what we call a scene. So imagine taking all of those individual scenes and compositing or mosaicing them into a single image. So we create global monthly base maps so that way you can get a clean image. They are visual, so they're just including the RGB data, but it is something that a lot of people are finding useful for training machine learning models. You also have access to the RapidEye Global Archive. This is a retired satellite constellation that Planet acquired earlier on. I'm blanking on the actual time frame, but it is a retired satellite since 2021, I want to say, but this is about a 5-meter, 5 spectral band data product. Then we also have SkySat on your contract as well. So not only do you have access to the SkySat archive, the SkySat archive is based off of where people have tasked in the past. We have a rolling window of 6 months or older. So the latest image in SkySat that you'll have access to will be 6 months old, but that's a rolling window, so it'll update every day. And then of course, you also have access to tasking. So if you need an image now, you can actually request to go in and task an image over a particular place. This one is also upon request because there is a limited availability. So again, I encourage you to reach out to Jeff to kind of help facilitate those requests, but that is available to you as well. We just talked about those planetary variables. We have a lot of documentation around these planetary variables on our developer center, and I'd be happy to share with you that information, but that'll run through how we actually derive these products. That might be helpful for you. And then you also have access to a variety of different web applications and tools that Planet offers. So you have access to things like Planet Explorer. So actually, if you see the image to the right, this is just a quick little screenshot of what Planet Explorer looks like. This is essentially a place where you can go in and search the catalog of Planet imagery. And then you can preview the imagery and then place your order. Base Maps Viewer, it's very similar, but just for base maps. Planet Stories, which is a great little visualization tool to create a quick little time lapse. A lot of folks use this for in the classroom just to teach the power of having Earth observation data. Then you also have access to Planet's APIs, which are solely for pretty much data delivery or bulk downloading. So you can download or you can put in a bulk order and deliver that either locally or you can deliver that to a cloud storage destination. So they're really flexible in that way. We also have GIS integrations, which are ways in which you can actually pull up Planet Explorer into your GIS workspace, that being ArcGIS Pro, QGIS, and basically visualize data without having to download it, which can be really useful if you're wanting to see how it's interacting with other raster or vector layers. And then you also have access to Planet University and Community, which are platforms that our customer education team run. Planet University provides you a variety of different online trainings, on-demand trainings as well. And then Community is a great place to basically go and ask questions, search for questions, present your ideas on what Planet should do next. It's a great way to kind of get engaged with the Planet user community. We're actually seeing a lot of really exciting conversations taking place in Community, which is awesome, which is a great time actually for you all to be involved in Community now with the release of the Planet Insights platform, which I just so happened to put the slide next. So it's a great segue. But about a week and a half ago, Planet released the Planet Insights platform. And so you might be wondering what this is. And essentially, at this moment in time, the Planet Insights platform is the name that we've chose to kind of describe all of the platforms, web applications, and tools that we have within Planet's suite of offerings. And so basically this includes, I think I have that, my next slide. Oh, well, this is actually just a quick example of the way that we're thinking about the future of Planet. So like I mentioned before, Planet has historically been a data provider. We've been collecting imagery and we're delivering that imagery. Well, of course, the value of our imagery is within the insights that you can derive from it. And so Planet is taking this approach to provide these insights and these tools in front of you so that way you can get to these insights faster or automate these insights. And so we're kind of doing some rebranding and trying to build the tools that you all will use in the future. And of course, this slide in particular is a little more commercial focused, but I'd be very keen to learn how our academic community might utilize tools like this. And so kind of the overarching idea here is we want to centralize all of the Earth data. We want to find ways in which we can scale and hasten our analysis capabilities. We want it to be flexible so that way we can operate across different ecosystems. I'll talk a little bit more about that. But finally, use this information to actually make change happen and speak with the people who are making the decisions. Okay, so this is kind of the breakdown that I was getting to, which was, Planet has historically been the data provider. So we've been providing data. You go to our platforms, search it, order the data, download it locally, upload it to the cloud, and then do your process elsewhere. However, with the acquisition of a company called Synergize back in August of last year, who runs the platform Sentinel Hub, we have basically cut that down and we've started to integrate a cloud-based processing platform called Sentinel Hub into our workflow. And the idea here is to help you with your analysis without having to do this cumbersome data download. You'll have a place on the cloud to actually analyze this data to enable you to actually make the necessary changes faster. And so kind of what this looks like is on the left side here, you see Earth data, broadly speaking. So within the data that we're providing, this is historical. This is kind of like where Planet was, and the rest of it's kind of where Planet's going. But we have access to things like the public data set. So Sentinel imagery, Landsat imagery are all available through Planet's platforms, as well as even Sentinel-1 data. And then, of course, you have access to all of the other Planet data. So Planet scope imagery, SkySat tasking, SkySat imagery, our base maps, and our planetary variables. And then we're also wanting to help facilitate bringing your own personal data into the platform itself. So if you have very particular information that might help train your models over this imagery, you can bring that in. And so the idea is that we can use platforms like Planet Explorer, which you have access to, as well as our EO browser and our APIs to actually collect this data and then utilize you can visualize and analyze using things like EO browser, which is equipped with scripting capabilities where you can derive insights, and then actually use the Sentinel Hub platform to do processing on the cloud. And so basically what this means is we have these processing tools that are enabling you to be able to be flexible. So what we're seeing is a lot of people are calling to the Sentinel Hub APIs, and the results of whatever model that you're putting into Sentinel Hub will be output in an external facing tool. And so what we're hoping is that we're building the back end so that way we can populate the front end of whatever tools that you're trying to create. And this can be on the side of web applications. This can be implemented into GIS platforms. And so we're really excited about introducing this capability to everyone. And through the education and research program, we'll be keen to figure out how we can leverage your expertise here. Okay, and for the sake of time, I'm going to rush through the remaining slides because we've talked in detail about many of these different things. We have discussed the data delivery options being through web applications, through the APIs, and through our GIS integrations. And quickly here is just a breakdown of what you all have access to again, Planet Explorer. Again, your ability to actually search Planet's catalog of imagery, similar thing with Base Maps Viewer. Planet Stories, you just saw a quick little graphic down below of Lake Isabella in Southern California, and just showing you how a powerful visual using Planet Stories can be when it comes to things like education or even showing off particular research studies. And then, of course, the tasking dashboard, which is there for you to be able to task. But of course, this will be upon request. Planet integrations in ArcGIS and QGIS, Planet Explorer within your GIS workspace, which is awesome. For those who are wanting to do a lot of cloud-based processing using Google Earth Engine, we do have a workflow to deliver our data to Earth Engine, which you can find on our developer center here. And then finally, Sentinel Hub. We kind of talked about this a little bit. This is the newer platform that's being integrated into the Planet Insights platform, more broadly speaking. And this is really going to enable you to start doing cloud-based processing and allow you to build out new tools where you can deliver this data to. Currently, right now, this is not technically part of the education and research program at the moment. But what we've done is anyone who has a Planet account, whether you created it yesterday or you're going to create it tomorrow, if you create it, everyone with a Planet account is eligible for a 6-month free trial. And this includes free processing units and the ability to go into EO browser and peruse all the different analytical features that we have. So I highly encourage you to check that out. I have some more slides about that toward the end. All right, so you've kind of gotten a sense of where Planet is currently. We're working on a lot of things, but of course, we're always looking ahead. And so I wanted to introduce to you a couple of new constellations that Planet is focusing on over the next few years. So you've seen information around our Dove satellites and SkySat. So we're actually planning on venturing into a couple of new territories, one of which being a hyperspectral satellite. So we have the Tanager mission scheduled to launch later this year, or at least our tech demo version. But the Tanager satellite or sensor will be equipped with 400 spectral bands ranging from 400 nanometers all the way up to 2500 nanometers with a 5 nanometer interval in between each band. And so it's going to unlock a lot of new potential. And I have a slide next that'll talk a little bit about our initial plans with this, but the tech demo is planned to be launched later this year. We also have the Pelican mission, which is the upgrade to SkySat. And we're planning to have a constellation of up to 30 of these satellites. And we're hoping to achieve a spatial resolution of up to 30 centimeters. This will be equipped with 6 spectral bands, as well as a planned 30 revisits per day. This will be over very particular areas on planet Earth. But based off of our demand with SkySat, we kind of know the hotspots of areas that our customers are interested in tasking over. So you can just think of this as a higher spatial resolution SkySat satellite. With hyperspectral, the plan really got started with a partnership with Carbon Mapper. So we're partnering with JPL and Carbon Mapper in producing this satellite. JPL produced the sensor itself, and Planet was responsible for the bus. And so the idea is that we can utilize very unique pieces within the electromagnetic spectrum to identify pinpoint sources of methane emission. And so this is really exciting because this gives us an opportunity to actually quantify the amount of methane that is being emitted and identify areas that are responsible for these types of emissions. And so that was what really kicked off this satellite mission. And so we're really excited about this one. But we also are very aware that there are going to be a variety of other use cases as well. So we're really excited for the academic community to start utilizing this data to show us what else it can be used for. And I have a couple of little images. This is what Pelican looks like in the back room. And then this is a little sneak peek of what the Tanager satellite looks like. Okay, I'm going to run through some of these so we can open it up for some questions. But broadly speaking, I am just a piece of Planet's overall science programs. So I work within the education and research program. And actually, this is where the U of A's license is through. And so we also offer data to a variety of other scientific areas. So we work with NASA. We have a commercial small satellite data acquisition program, SISDA for short. But basically, anyone who's federally funded can also access Planet data through this mechanism. And then, of course, we have partnerships with the European Space Agency, as well as RISA and the Norway International Climate and Forest Initiative, also known as NICFI, which are producing monthly surface reflectance base maps over the tropics of the world. And so this is to help research deforestation and help make a positive impact from that angle. But these are all the different science programs that are active that folks might be interested in accessing data through. I might be biased, but the education and research program is the best. So we offer the most and the most diverse data sets through this program, but we are also really excited that we have other avenues for which people can gain access. Kind of zooming out, looking at the science programs more broadly speaking, we have about 20,000 users across all of our science programs. We have well over 3,000 peer-reviewed publications at this point in time, which is just really exciting. It's a huge testament to the integrity of our data and the excitement around folks wanting to use that. We actually have, that's a funny one, users at over 100 universities. I would say like well over 500 universities, but we work directly with around 100 universities worldwide. And then we also have engagements with around 30 different US federal agencies for scientific purposes. And then, of course, we're offering all sorts of different ways that folks can access this data. And just within the science community alone, the amount of data that people have downloaded is greater than 5 times the entire Earth landmass. And I'd argue that this stat is out of date as well. I'd probably say closer to 10. And here's just a quick little spatial breakdown of who our science community is. You can kind of see all the countries are shaded differently based on the number of users. And all of these dots here are universities who have paying engagements with us through our education and research program, including U of A. So looking at some of the publications that have come out of the science community, these are just a few. Like I mentioned before, we have well over 3,000, but here are just a few that are just really exciting to me. We have some folks out of Duke University who are utilizing that deep historical stack of Planet imagery to actually build out and quantify PM 2.5 across particular areas. So they have like a network of sensors across different cities, and they're using Planet data to actually train these sensors to quantify the amount of PM 2.5 in the air based on the level of haze that is present in the imagery. And so this actually is providing a lot of spatially distributed information where the sensors aren't located. And so this is helping provide a lot of information across different cities with a sense of knowing what air quality is like. We also work with some folks over at UC Davis who are utilizing a ton of PlanetScope imagery to actually map and predict tree mortality and survival post wildfires. So obviously in California and the Southwest, more broadly speaking, wildfires are having a huge impact on many different industries. And so being able to actually use satellite imagery to help understand trends around wildfire impact are incredibly important. And then this last example here, this is actually what some folks out of Enrique Vivoni's lab at ASU, the Center for Hydrologic Innovations. But there's a postdoc there, Xiaocheng Wang, who we work very closely with, who are utilizing PlanetScope imagery to actually map stream flow. And so with stream flow and ephemeral waterways, every so often there's some gaps in data. And so being able to utilize spectral information to actually see if water is present or not is really critical for managing the state of Arizona's water resources. And so that's a really exciting way that folks are kind of being innovative with using spectral data and having it updating so frequently to be able to even create these monitoring type workflows. And most recently, we had some community-led webinars. And so we have this webinar series called Planetology. We just put on our first one a couple of weeks ago, which was focused on forestry. And so we actually had Dan Dixon, whose work I just presented on. We had Matt Hansen and Ali Shankin, who's from Northern Arizona University, all present the work that they are doing in regards to forests across the world. This was our first iteration of this webinar series, and it was widely attended. So we're really excited to be putting on our next iteration of this in a couple of months. We're going to be doing these on a quarterly basis. And so I think our next one will be water resources, but it was a really great way for us to kind of help build the planet science ecosystem. So we're really excited to be putting things like this on. And another way that we're helping build community is through our platform, Planet Community, which is basically a web forum where you can go ask questions. You can go seek out answers to your questions. You can provide ideas for what Planet should do next, as well as stay up to date on different product announcements. One of my favorite examples of how Planet Community has been utilized is actually a PhD student who we were working with. He is mapping out mangroves across the Caribbean. And he went to Planet Community asking, if people had advice on mapping out mangroves in the Caribbean. Well, it turns out a researcher from the University of Trinidad and Tobago just so happened to see the post, communicated with this individual, and now they are actually collaborating on papers together. And so this was a really good example of how just posting information about the work that you're doing can actually lead to future collaborations with other Planet users in the ecosystem. And so these are the types of stories that we want to tell more of. And so we'd be happy to invite you to Planet Community, not only to share your ideas, share your research, but also just learn from one another. And then we also have different trainings on demand for you. So you got a very high level overview of what Planet is, the data that you have access to, how you can access it. But we have more training available to you through Planet University that will break it down much further. Once you have data in your hands, what can you actually do with it? And so I highly encourage you to check out Planet University. You can go there, university.planet.com. There's a ton of different trainings, including our new trainings for like the Sentinel Hub. Also on Planet University are different lab exercises. So for those who are interested in bringing Planet data into the classroom, we have a variety of different off-the-shelf training modules, lab exercises that you can implement into your course. So things like, mapping tree blooms using ArcGIS Pro, or going through the basics for doing image processing in Python, all the way to mapping algal blooms or even calculating changes in water levels. We're actively producing more and more of these types of materials. And so we're actually partnering with folks like Esri to help produce new materials for ArcGIS Pro. But we're also looking to our academic community to help ideate on what might be next. And so how we might want to highlight different types of image processing utilizing other tools like Python or Q, GIS, and so on. And then lastly, I wanted to again reiterate the 6-month free trial that we have going on with our Sentinel Hub and EO browser platforms. So think of Sentinel Hub as a tool of APIs that you can call to do cloud-based processing, and EO browser being the visualization tool. So on the left here, if you go to university.planet.com, we have a variety of different trainings on Sentinel Hub. So if you're wanting to get your hands dirty and do some coding, this would be a great platform for you to go check out. And then on the other hand, we have sandbox data. So we've already populated our EO browser with some Planet data. We've populated it with planetary variables. So that way you can kind of see what it would look like for you to access this type of data. And so I believe that's my last slide. I'm happy to pull up the sandbox data, but I'm also happy to answer any questions that people might have.
Hey, thank you, Austin, for the rundown of everything. Really appreciate it. I learned a few things for sure. Does anyone out here in Zoom land have any questions for Austin? Could be anything. So Dave in the chat is asking, what's the file format of data when you download it?
Great question. So whenever you download, let's just say it's a planet scope image, you'll get a zip file with a TIFF file in it. So it'll be a raster image. You'll have the actual image itself, and then it'll also be you'll also have a UDM layer attached to that as well, which is another TIFF file. But basically, our UDM is our usable data mask. And this is, we run this on every image to produce a cloud layer. So that way, for those folks who are wanting to do any sort of cloud masking, we have that layer available for you. So you can use that. And that comes attached to every download. And you can choose what type of image you download as well. So it can be just a 3-band visual image, or if you want to do analytical work, you can download the surface reflectance data products or the top of atmosphere data products.
Anyone else have any questions?
Carlos just had a good one about COGS, so cloud optimized geotiffs. We do actually. If you essentially, if you utilize our APIs and you're delivering it to cloud storage, you can toggle the type of file format you want. So it can be delivered as a cloud optimized geotiff. So that is available to you as well.
Yeah, okay, thank you. Okay, thanks, Eric. Yeah. Eric's saying he very much appreciates it.
It was a ton of information, and I don't blame you all if maybe some of that was just a bit too much, but there are tons of resources for you online. So I just keep encouraging everyone to go to Planet University because it's such a great tool for you to just get up to date, up to speed on everything that we have going on.
I have questions about the Sentinel Hub. So it's retaining that name, right? Sentinel Hub is going to be still Sentinel Hub with Planet.
Yes, and so I don't know like the future of what it will be called eventually.
Okay,
If
but
it
for
will
now,
be,
it's still Sentinel Hub.
yeah, for now it's still Sentinel Hub, and it's like I mentioned before, like Planet Insights platform is this umbrella term that encompasses the suite of web applications and tools, and so Sentinel Hub has the processing, the cloud-based processing APIs. So
Okay, and
we'll
is
call
it
Sentinel Hub for now.
Could you compare it in ways to Earth Engine or Planetary Computer? Is it kind of work like one of those in some regard?
Yeah, that's probably the closest comparison that I can think of is like Google Earth Engine. I haven't used Planetary Computer all that much. I'm a little less familiar with it, but from an Earth Engine perspective, it seems comparable in ways, but it almost seems a little more flexible in kind of like where you want to build something.
Okay.
So, anyways, I don't want to dive into the weeds because I don't want to.
Yeah.
I'm still learning Sentinel Hub, so there's a lot for all of us to learn here. But it feels like it's a bit more flexible in the way that you can utilize it and where you can build out tools, which is actually really exciting.
Great. Okay, Matina, go for it.
Okay, I have a couple questions. So one is, what is the spatial resolution on the upcoming Tanager?
Oh, good question. I totally didn't say that. And now I need to go back and add that to the slide. So the spectral or the spatial resolution on Tanager will be 30 meters. So it's a bit coarser than PlanetScope, but that's kind of the trade-off with having a much higher spectral resolution that Tanager has. So it'll be 30 meters, and it'll also be like a tasking satellite, so similar to that of SkySat and Pelican. So basically we're capturing data over places that people are requesting.
Okay, and then one more question, if I can. The Planet University resources, the sort of like classroom stuff, like this looks very exciting to me. Is this openly available or available only like by subscription? I'm not sadly at U of A currently, although I once was.
That's a good question. From my understanding, I think you have to have an account, but you don't necessarily have to be tied to a specific subscription. So we have a basic education and research program, which anyone who's affiliated with an institution can access it. And so from that angle, you can register for any of those online trainings. So anyone who has an account can effectively get access to the training materials.
Okay, great. Thank you.
Yeah, I used material from the Planet University for the API course that I did the very beginning of the semester. So yeah, it's just full of kind of like useful tidbits on how to do data science stuff with Planet Imagery. It's nice. See, Carlos brought up Stack in his comment also. Do you guys index your catalog in Stack? Do you guys use spatial temporal asset catalogs at all?
Yes, we do. I don't want to speak too much because I'm still learning Stack, but we do work, or Chris Holmes works with us.
Okay.
So, and I know he's like the Stack overlord.
Yeah, he's Stack
Um,
guru.
so, our data is set up in a way that Stack is like recognizes it, if I'm understanding Stack correctly. But we do try to adhere to those types of things.
Okay, cool. I'll check it out. Anything else from anybody? Carlos, what do you got? Anything else? Anything else you really want to know? We got Mr. Planet right here.
I think he answered most of the questions.
Maybe I'll just say one thing is, the U of A has access to a lot of different data, which is really exciting. Part of the education and research program is, to enable our research community, our academic community to engage and experiment and, just expose themselves to this type of information. So I highly encourage you to jump in, play around with it. If you have questions, you have Jeff's email, so you can send him all your questions. But also, Planet Community is another great place to jump in as well, just to learn from others and seek out how other folks are using Planet data.
Hey, all right. Well, we're a few minutes early, but thank you very much, Austin, for coming by. You're actually in Denver, right? Is that where you are at the moment?
I am based in Denver, but I was just recently down visiting Tucson, and
Yeah.
I'm sure I'll be back soon.
So yeah, thank you so much for joining us in NextGen Geospatial, talking a little bit about Planet. I think I have a better idea on some stuff, so I really appreciate it. For everyone else on the call here, if you guys don't have access yet, let me know. You can just send me an email or go to that link. Let me hit that link again. in the chat. This is where you can kind of directly sign up to get access as a student or a researcher, and then we can turn on your account, and then you can get in and start getting some planet imagery for free. So yeah, if no one else has any comments or questions, then we can leave it there. So thank you very much for attending. Next week will be the last session of the semester, and we're going to do a little bit of deep learning on drone imagery. I'm probably going to there's a software program, a Python library called Deep Forest that's been pre-built for identifying trees and birds, which is pretty cool. So I'm going to dive into that a little bit. It's from a group at University of Florida, and apparently their applications were forests and identifying birds in the Everglades. So they made us a nice a deep learning package, basically. So they pre-built a convolutional neural net model that we can just get and download their Python package and use it right out of the box. And I played with it, and it will identify trees down in Santa Rita, where I've done a lot of my drone flying. But they encourage you to do your own little like fine tuning with the training to make it really fit your area of interest. So we'll talk about kind of how that works. So hopefully you guys will tune in next week, and then that will be the end of the semester, and we'll see you back in September after that, I guess. So we'll again do this seminar in fall of 2024. So thank you very much, and see you next time. Thanks, guys.
Thanks for having me.